If a swarm of hostile weaponized drones penetrates the domestic airspace over a city like Chicago or Los Angeles, the military's options are physically limited. For decades, the primary defense against aerial threats has been the Patriot missile system, shown here. It's a proven tool for the open battlefield, but it is not designed for urban use. These interceptors are kinetic weapons. They rely on high-velocity impact and massive explosive charges to shred an incoming target with a dense cloud of shrapnel. Firing these over a city creates a terminal velocity hazard. Hundreds of pounds of jagged, burning debris from both the missile and the target maintain enough momentum to penetrate rooftops and strike civilians in the streets below. In a domestic setting, the falling wreckage from a traditional missile interception often causes more structural damage than the small drone it was meant to stop. Beyond the physical danger, the economics of modern air defense are unsustainable. The military is facing a massive cost imbalance in asymmetric warfare. A single advanced interceptor missile costs $4 million. The commercial drone it targets costs roughly $2,000. If an adversary launches 50 drones, a defense battery exhausts $200 million in minutes, leaving the area defenseless. These combined physical and economic constraints create a gap in the national defense shield. Protecting the homeland requires a shift from kinetic projectiles to a different branch of physics. The military is closing that gap with directed energy weapons. This photographic source shows a high-energy laser array, a system fast-tracked for domestic deployment. The centerpiece of this effort is the U.S. Army's Palletized High Energy Laser, the P-HEL. It is a modular 20-kilowatt system designed for rapid integration into existing defense networks. The P-HEL does not fire a physical round. Instead, it generates a concentrated beam of light that travels at 186,000 miles per second to deliver focused thermal energy to a specific point on the target. This thermal energy melts through the drone's outer housing. Within seconds, the heat fries internal circuit boards or causes onboard lithium-ion batteries to combust mid-air. Because there is no explosion, there is no expanding cloud of shrapnel. The drone is neutralized without creating a wide debris field over the city. By utilizing heat instead of kinetic force, the military can finally intercept aerial threats directly over populated areas without endangering the people on the ground. This shift to thermal energy also provides a permanent solution to the cost imbalance that makes missile defense so expensive. The laser's power source is remarkably simple. The system runs on standard industrial-grade diesel generators that are already common in the military's logistical chain. A single laser shot costs roughly $10. The military can destroy a $2,000 drone for a fraction of the cost. This creates an infinite magazine. Unlike missile launchers, a laser battery fires continuously as long as the generator has fuel. This sustainable, low-cost magazine provides a logistical advantage against mass-produced drones, ensuring the defense never runs out of ammunition during a swarm attack. These systems are no longer experimental prototypes. They are currently being integrated into the nation's permanent defensive posture. This map illustrates the strategic deployment of a domestic laser dome, a network of overlapping defensive rings positioned to guard the country's most vital sectors. The P-HEL is specifically tasked with guarding civilian vulnerabilities, such as the high-voltage power grids and electrical substations seen in this night shot. The protection also extends to military staging areas, like the one pictured here, where billions of dollars in aircraft and assets are currently exposed to low-cost aerial threats. In an era where cheap, accessible technology can be used to disrupt a national economy, high-energy lasers have become a requirement for survival. Safeguarding the modern American skyline now depends on the precision of thermal heat, delivered at the speed of light.